Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss difference between multithreading and multiprocessing in Python. So if you are ready, let's start today's video. Multithreading and multiprocessing are two approaches to achieve concurrent execution in Python, and they have distinct characteristics, use cases, and trade-offs. In this comparison, we'll explore the differences between them in Python. 1. Basic definitions. Multithreading is a concurrent execution technique where multiple threads share the same process and memory space. Threads are the smallest unit of execution within a process, and multiple threads can run concurrently. While multiprocessing involves the use of multiple processes, each with its own memory space and resources. Processes are separate instances of the Python interpreter and have their memory and global variables. 2. GIL or Global Interpreter Lock. Python has a Global Interpreter Lock or GIL, which allows only one thread to execute Python code at a time. This means that even with multiple threads, true parallel execution of CPU-bound tasks is limited. While in multiprocessing, each process runs in a separate interpreter, so the GIL is not a concern. This allows for true parallelism, making it suitable for CPU-bound tasks. 3. Performance. Multithreading is suitable for I/O-bound tasks like network requests, file I/O, or database operations, where a program can benefit from the concurrency of multiple threads without the need for true parallelism. While multiprocessing is ideal for CPU-bound tasks that require true parallelism, such as numerical computations, data processing, and heavy computational workloads. 4. Communication. Threads share memory, which can simplify communication between them but can also lead to data races and synchronization challenges, which must be managed using locks and other synchronization primitives. While processes have separate memory spaces, so communication between them is typically done via interprocess communication or IPC mechanisms like pipes, queues, and shared memory. While this adds some complexity, it avoids many of the common concurrency issues. 5. Scalability. Due to the GIL, multithreading might not fully utilize multiple CPU cores for CPU-bound tasks, limiting scalability. It is better suited for scenarios where the bottleneck is I/O or other external factors. While multiprocessing can efficiently utilize multiple CPU cores, making it highly scalable for CPU-bound tasks. It can take advantage of multi-core processors effectively. 6. Code portability. Code that relies heavily on multithreading might not be as portable across different Python implementations, for example, CPython, Jython, IronPython, due to differences in the GIL implementation. While code using multiprocessing is generally more portable because it avoids GIL-related issues. It works consistently across Python implementations. 7. Memory overhead. Threads share memory, which can lead to higher memory overhead and potential issues like memory leaks. While processes have separate memory spaces, which can increase the memory footprint. However, it reduces the risk of memory-related issues affecting multiple processes simultaneously. 8. Use cases. Use multithreading when dealing with I/O-bound tasks, building responsive user interfaces, or running tasks concurrently without CPU-intensive calculations. While use multiprocessing for CPU-bound tasks, such as data crunching, numerical simulations, and parallelizing workloads to fully utilize multi-core processors. 9. Complexity. Multithreading can be simpler to implement for some tasks that involve concurrent I/O operations. However, it can become complex when dealing with shared data and synchronization. While multiprocessing can be more complex due to the need for inter-process communication and managing separate memory spaces, but it offers better isolation and avoids certain concurrency issues. 10. Libraries. Python's threading module is commonly used for multithreading, while the multiprocessing module is the primary choice for multiprocessing in Python. In summary, the choice between multithreading and multiprocessing in Python depends on your specific use case. Multithreading is suitable for I/O-bound tasks and scenarios where concurrency is more important than parallelism, while multiprocessing is better suited for CPU-bound tasks that require true parallelism and can fully utilize multi-core processors. Understanding the differences between these two concurrency approaches is crucial for making an informed decision when developing Python applications. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.